So I want to take this expression right here, 4x squared minus 100. And when you take a look at that expression, you might recognize that you've got kind of really two perfect squares going on there, because 4x squared could be created by a 2x times a 2x, and then also 100 could be created by a 10 times 10, and there's no middle term. And so, like, if you do try factoring that expression as 2x, and then make one a plus 10, and then 2x, and then a minus 10, it turns out that that is a correct factored form of the expression that you would see right there. Now, however, there is an issue with that particular expression because it actually is not considered to be factored completely. And the reason why that is because if you take a look at that factor right there, you can actually break that down a little bit further. And I know it's linear, it's a 2x plus 10, but it turns out that 2x and 10 actually have a common factor, right? So you could actually take that 2x plus 10 and factor out a 2 and then make it 2 times x plus 5. But then it also turns out that we have kind of the same issue with the 2x minus 10 factor, that you could factor out a 2 of that and then make it 2 times the quantity of x minus 5. So we were able to take that expression and then turn it all the way down to what I just highlighted in the green right there, which is a 2 factor times an x plus 5 factor times a 2 factor times an x minus 5 factor. So because of the commutativity and associativity of multiplication and such, then of course we can do the 2 times the 2, so then we would get 4, and then times x plus 5, and then times x minus 5. So now that linear factor doesn't have any other common factors, and same thing right there. So it does turn out that this would be the fully factored form of that expression. So we can get every expression factored down all of the way if we approach things like that in that manner. It just turns out that we can probably actually always make our life easier if we actually do this here first, and that's to factor out the common monomial factor first. So if I took that problem once again and we do what we should always do when we factor and check for a GCF first, you'll actually recognize that 4 and 100 are both divisible by 4. So if you take out that common factor of 4 first, then it's equivalent to 4 times that x squared minus 25. And then if you think about x squared minus 25, that is a difference of two perfect squares, which means that you're able to factor that further as then x plus 5 times x minus 5, and then lo and behold, we end up getting the same answer, of course, but a little bit more efficiently, a little bit faster. So point is that we should always check for a GCF first, and usually that makes your life a little bit easier. But you'll always end up with the same answer as long as you take all the correct steps, of course. So then I want to jump down to here and consider if we have 3x squared minus 75 and think about, okay, could we factor something like that in like the two different ways that we did with the 4x squared minus 100? So if you think about first of all, factoring out GCF first, maybe. You can take out a 3 and then end up with x squared minus 25. And then the x squared minus 25, of course, breaks down in the same way that we just did. So it ends up factoring all the way down to there once we get it completely factored. So if we think about the other way, meaning we don't take out the GCF first, I don't think we can because 3 is not really a perfect square, right? So if we were to try to think about, okay, and the same thing with 75, right? So we can't really do it the other way with that particular expression that we're dealing with there.